Hey there, if you're checking out this video, you've probably already watched a video or know how to factor quadratics where the a is equal to 1, where the coefficient is equal to 1. Today we're checking out when that number out front is greater than 1. Let's get it. All right, so you should be able to know how to use the factoring strategy with the box method. So today we're going to jump right in to factoring when the number out front of the x squared is greater than 1. We're going to do the same thing that we did. We're going to put 2x squared in a corner. We're going to go ahead and put the 7 in the other corner. Here's the key. The key is factoring means multiplying. Multiply this diagonal. 2 times 7 is 14. Let's say you don't do this. Let's say you just try to factor 7. Does that add up to 9? Nope, it does not. So we don't have the factors. You might be thinking, oh, this one can't factor. Well, the key when you have this number out front is that something has to get doubled. So the key right off the bat on this diagonal is 2 times 7 is 14. Let's go ahead and factor 14. Do you see a way that we can get 9? 100% I see it. It's 2x and 7x gets me that 9x. So we're doing the same exact thing that we were doing before, but we're just checking out that first diagonal and making sure that we actually multiply. That's what factoring is, finding things that multiply. We multiply that diagonal, and then we go ahead and make our factor chart. Cool, I still like focusing on the x squared, x times x, but what's a little bit different now is we have this 2 out front. So where does the 2 go? Does 2 go into 7? Nope, it does not. Does 2 go into 2? Yep, so I'm going to put a 2 on the top so that it goes to that column. How many times does 2 go into 2x? Just one time. How many times does 1 go into 7? Or how many times does x go into 7x? That would be 7. So I'm giving you a lot of visuals there, a lot of scribblies, but it'll probably go a little bit quicker in our next one. We got 2x plus 7. And then x plus 1. If this does make sense to you, make sure you check out the purple problem at the very end. Don't go too fast through the video. There's something different in that purple problem at the end. So what do? We go ahead and we set up our 2x squared wherever you want. Check. Then we have our positive 7, and we put that anywhere. Check. The key is this diagonal. 2 times 7 is 14. We go ahead and factor 14, just like we did on the last problem. And we're looking for ways to get 15. I see I can get 15x if I use a 1x and a 14x. It doesn't matter where I put them. All right, let's go ahead and focus on the x squared. That's an x times x. Where does the 2 go? Does the 2 go into the row, or does the 2 go into the column? 2 doesn't go up into 1. 2 goes into 14. How many times does 2 go into 14? Well, 2 goes into 14 7 times. And then we can check, how do I get 7 to go up and get to 7? 7 times 1. And that also matches up 1 times x in that box. There's a lot of scribblies as I'm drawing them here, but I'm just going ahead and showing you how you can kind of double check your work. So we've got an x plus 7 on the bottom on our base, and then our height is a 2x and then a 1. All right, now we got 3x squared. You can, again, go ahead and put it wherever you want. It doesn't matter what corner, but that 6 has to go in the opposite corner. The key is to multiply the diagonal. 3 times 6 is 18. Go ahead and make your factors of 18. I think that's all of them. I'm looking for a way to get 19, and that first option is going to work for me. I can put 1x and 18x. It doesn't matter where they go, but that's going to give me the 19x. Focus on the x squared, x times x. Where does 3 go, into the row or the column? 3 does not go into the 1 over there. 3 goes into the 18. So 3 goes into 18 how many times? 6. 6 goes into 6 how many times? 1. And you can check that last box over here. That 1 times x gets you 1x. So we've got 3x as our base, plus 1. On our height, we've got an x plus a 6. We got another 3x squared. I'll put it here instead. You can put it wherever you want, 3x squared, as long as you put the 6 in the diagonal, because the key is multiplying that diagonal. If I didn't do that and I just did 6, is there a way to get 11? No, there is not. So the key is multiplying that diagonal. Factoring means multiplying. So multiply 3 times 6, that is 18, or technically 18x squared. I factor 18, and is there a way to get 11? I see it. I can get 11x if I do 2x and 9x. It doesn't matter where I put them. Focus on the x squared. X squared is x times x. Where does the 3 go? Does the 3 go into the row, or does the 3 go into the column? 3 does not go into 2 unless I'm using decimals. 3 goes into 9. So I'm going to put the 3 going into the 9 3 times. How many times does 3 go over into 6? That would be 2 times. And we could double check that last box, that 2 times x equals 2x. So just doing a bunch of mini multiplication problems. Our base has 3x plus 2. Our height has x plus 3. And I have factored. We got 2 more. Save, hang on for the problem at the end. 4x squared, put it wherever you want, as long as that positive 3 goes in the other diagonal. If you just factored 3, it wouldn't work. So factor that diagonal. 4 times 3 is 12. We should be factoring 12x squared. So 1 times 12, 2 times 6, 3 times 4. Ooh, that's how I get 7. X is if I use 3x and 4x. Again, it doesn't matter where I put them. X squared is x times x. 4 is definitely going to go into the row, so that 4x goes into 4x. That's obvious. 1 time. 1 goes into 3 if I did 1 times 3. And then x, 3 times x will get me into the 3x in that last box. All right, so I've got 4x plus 3 on one side and x plus 1 on the other. And purple problem, here's the challenge. Pick the 4x squared wherever you want it. Check. Put the positive 3 in the other corner. Multiply that diagonal. 12x squared. 1 times 12, 2 times 6, 3 times 4. I see a way to get 8x if I use 2x and if I use 6x. What does x squared is x times x. I jumped ahead of myself. I was ready. What does 4 go into? Does 4 go into 6? No, only with a decimal. Does 4 go into 2? No. 2 goes into 4, but does 4 go into 2? No. So where do I put the 4? Guess what? I don't put the 4 anywhere. I now have to factor the 4. I'm looking for common factors. If you remember our first day of the lesson where you printed out that worksheet, we're looking for things in common. So 2 goes into both 4 and 6. And 2 goes into 4 and 2. So instead of just putting the 4 on one side, I'm going to go ahead and split it into 2 times 2. How many times does 2 go into 6? That would be 3 times. How many times does 2x go into 2x? That is just 1 time. And double check your last ones of 3 times 1 is 3. So just because you have a number out front, this 4x squared, doesn't mean that you're going to have a 4 in your answer. It might work out that way. It might not. You might have to factor it or break it up into a mini multiplication problem. We've got 2x plus 1 on the top, and we've got 2x plus 3 on our height.